Right. So basically, what we did was yesterday, what we had done, I'll just give a small uh, like a recap of what we did do. First and foremost thing, from linear data, we actually jumped to non-linear data. Obviously, that was done earlier itself. From non-linear data, this time we jumped to there is small loss function that we introduced, and due to that loss function, what was the difference that started happening? That now my model started learning the categories, right? Now instead of continuous data, my data was discrete data. That is, discrete learning started happening, right? This was discrete learning. It could be 2D, 3D, whatever was there, it started happening, right? And then basically we actually jumped to our image classification data, because I mean this was also a classification data, but we were not just limited to simple classification, because we did a lot of extra steps. We tried to visualize, what was happening inside the model. We so that will come automatically in the video part, right? We tried to visualize that what was happening inside the model. We tried to visualize that, okay, what happens to layer 1 when it is learning, what we are seeing in the layer 1, what is happening. And then after that we try to visualize, like, after what the model has trained, what is our accuracy and all sort of things. Now going forward, today we have to take a step forward. We'll have to introduce some of the standard practices, and we'll have to understand, like I said, once you have understood your data, there is 80% of the thing that we have done. So today we'll lay some very basic foundation of textual data. Right? So first and foremost thing, like, till now what we have been doing, we did not split the data, right? We did not split the data. Now, whenever you go ahead and you talk with anyone, who is who knows AI or your customer, they will usually talk in the terms of what is your F1 score of model, what is your F1 score of model, what is your recall, what is your precision, like, although not everyone understands, but yes, this has become what is your F1, and what is your accuracy, right? So although these terms may sound very complex, but believe me, these are just one liner formulas, and you have been practicing this in your 8th 9th standard, not even 10th standard. These are just 8th 9th standard things. I mean, nothing complex into it, right? But yes, I mean, these become important term. These are some of the important terms that we'll have to understand. So first and foremost thing, what we need to do is we need to always split the data. Now, all of these things, F1 score, recall, precision, accuracy, these all come into model evaluation. These all come into the category of model evaluation. We'll just see simple formulas for this, and then along with the formula we also have sklearn function, where through sklearn function we have already seen this library. We'll be able to calculate all of them automatically also, so you don't need to write the formulas every time, but we'll just have a quickly revisit at what these formulas are. So first and foremost thing, what should be the case always? The case should be always that whatever you are, your model should always be having two parts of the data. Let's say this is your train data. If this is your train data, this is your data, and your data should be actually split into training part and testing part, right? Now this training part is something, again, it will have X and Y, and this testing will again have X and Y. You should train your data here. Your accuracy will be calculated as per the training data. Sometimes this is a very huge jumble thing that even nowadays happens in the industries. They tell you that my accuracy, model's accuracy, because they have tested it on the trained data only, they will tell you that my model's accuracy is 97%, because you have trained on your data, so obviously your model's accuracy is going to be 97%, right? But if you say that my F1 score or my accuracy on the testing data, uh, can everyone just mute their mics, please? Right. So if you say that what is your accuracy on the test data, you know, what is your accuracy on the test data, then basically it might even drop to 77%, right? So this how huge the difference can be, 97% to 70% or 80%, whatever it may be. So similarly, F1 score is also related to your testing data. So this time it is related to your testing data. And your X, similarly, all of these things, the precision, recall, and all of these things are related to that. Now, this is not a new concept. I also don't want that you should be paying a hell lot of attention to that. But yes, I mean, these are some things. If you are, I mean, obviously now everyone is connected to AI. I mean, we can't say that if you are into AI word or not. So basically, these are the key terms where you need to, introduce your, I mean, you'll be talking with your maybe developers, or even sometimes now even customers know it. If there is enough educated customer, he might come and ask this, okay, that what is all of these scores, can you tell what is the evaluation of this model, right? Anyway, so we go forward basically. And here itself, I will very quickly, I mean, these are not very complex things. So first we need to split our data, splitting data into test and train. We need to split our data into test and train. So I'll take this same data here. This is what I loaded with the first. I'll go with the moon set itself, because it is easier to show all of the calculations in moon set. So here I have, and I have X and Y, and then I can use the split function from Scikit-learn. So Scikit-learn already has that split function. So basically I can just go ahead and use that. Let me just import, and the function name is from Scikit-learn dot model underscore selection. Now all of these things will fall under model underscore selection. Import test and split is automatically importing that, right? So this is basically used for splitting your data, although you can do it manually also, but no need of doing it manually. Splitting the data. Now once we have our X and Y, then basically let's start split. And splitting is very easy. Basically X and Y we have, simply I can go ahead and train underscore test underscore split, train underscore, although it is test underscore split. And we just need to provide in what ratio do we need to split X and Y. I'll just provide my X and Y here, X comma Y. And in what ratio do we need to split, right? Test size is equal to 0.2. 0.2 means 80% of the data we use for training. 80% of the data we use for training, right? We got this. Now next is, again we will go with X underscore train comma X underscore test comma Y underscore train comma Y underscore test. So these are some of the things we have. X and Y training, okay, right? So basically this is X underscore train, okay, we have this. And now what it has done, 80% of the data, total data was, let's say if length of X was, X is in capital, if length of X was 300, so what it has done automatically, X underscore train, so this is what it has done, 240, right? uh, right. Now although this is very simple, but there is a small thing, that simple things that you will have to understand, right? Because sometimes, because these concepts, they add up and they can confuse you. And then you will also have to learn basically a small, I mean, it is not again complex. You just have to learn that how do you read your confusion matrix, right? Again, it is a heat map. So we'll just have to go through the heat map, that will be our confusion matrix. And we'll see what is the confusion matrix. Okay, we have done it from here. And next is basically I need to convert it into tensor, as always, X underscore train underscore tensor. and x underscore text. And similarly, I'll go for y underscore train underscore tensor and y underscore test tensor. Right, this is correct. X underscore torch is not defined. Why do okay. Import torch. All right. Again, import numpy as np. Done. We are done. Next is my model building part. The model is equal to nn dot sequential, right? And okay, I have this model. It is picking up from my the data that I have above. So okay, I have this thing. Again, I'll have to import torch dot nn as nn and done. Right. And next is I need to write my optimizers. Okay, SGD and cross entropy, right? Again, done. Let it initialize. Okay. And after that, I will just have some epochs is equal to, let's say, 1200 epochs and loss underscore history, where I'll be storing my history. Loss underscore history is equal to this, and accuracy, and yeah, that's enough. And then for epoch in range of epoch, I'll name it as epochs, and that's it, I guess. It should give me model.train. And right, this is something we have been doing, but this time we are only training it on tensor, and this is why. So basically, as of now, what we are not doing is uh, basically I am not yet using the test data. So hence this is the point, that accuracy usually works only on your training data. I mean, usually the accuracy that is printed, it will only work on your training data. Okay, first let me just do this, and then we will also print the accuracy along with the epoch this time, right? Okay, this happens, this is working. I mean, no wonder in this, we have done it so many times. Now this time I'll add simple calculation, that calculation of accuracy. The calculation of accuracy is basically with torch dot no underscore grad. This is basically we are telling that, hey, just hold on, I'm doing these calculations myself, so you do not do any of these calculations yourself. So actually it has given me all of the code also. So output is equal to model of x dot tensor and prediction torch dot max of output, right? Output, and correct is equal to, I guess, correct predictions is equal to predicted is equal to y underscore test tensor dot sum dot item. So basically it is actually I can, for simplicity, if I can simplify it first, this whole function. So first we'll get is comparison. Comparison is equal to predicted underscore classes, right? So basically if y underscore tensor is equal to, now basically what is happening, it is comparing the whole data set altogether. I mean, I don't have to go one on one comparing. So these are the advantages that we get along with our PyTorch tensors. It is comparing my whole data set altogether. And then basically we just have to sum it off. And then after summing, I just have to take this uh, whole thing, right? So after summing it out, I mean, we are just, since it is a tensor, so I need this item thing. And here we have the correct number of correct things. And now I can print the accuracy. I can go ahead, and so my accuracy is going to be, what is my total prediction x underscore, okay, okay, I guess it is also giving me accuracy is equal to correct by length of y underscore test tensor. Okay, this is basically y underscore test. Now this is giving me accuracy with respect to testing data. of accuracy is equal to, although this should not be the case. Okay, I'll not confuse you. Hold on. Accuracy total prediction is correct prediction final count. Okay, I have all of and a correction prediction by total predictions. Y underscore train, Y underscore train underscore tensor, right? And yeah, we can see this. So basically, this is length function only, but since I'm taking it for directly from Y underscore train, so I'm as of now I'm not including test here, right? Then loss and accuracy is this. Okay, I'll go ahead and I'll print. So this is my loss and accuracy also. It is printing, and the accuracy is pretty bad here. Okay, hold on, I guess accuracy loss is going down, but yeah, loss is going down, so ideally accuracy should also increase. Correct is equal to accuracy in, right. Ideally will be accuracy into 100. Right. So it is stuck at 23.3, and correct is equal to, okay, this is correct predictor. Y is equal to test underscore tensor. It should be, I believe, Y is equal to train underscore tensor. Train underscore tensor. Predicted is equal to X underscore test. Okay, output already I am having X underscore test tensor form. Basically, output I'm already having. Okay. Okay, here we have the calculation was basically, since it was going off the way. I mean, not all AI generated code is correct, right? And hence we have to be very careful. Now, I'm just telling you that even with the best of best AI codes, please do not trust it. They will end up wasting a lot of time. These are tools. They don't own anything, and they don't have that intelligence that they can output you everything correct. So since now we have seen that how AI is working inside, so again, although this is I'm saying in recorded session, but yeah, let it be that AI is kind of wrong terminology that we have started using it, right? It is basically a neural network. It is a deep learning, right? That is the right terminology. But AI is a very huge canvas, and it kind of became nowadays a marketing terminology. I mean, anyone who hears that, okay, this is AI, and they will say, okay, we need to trust. No, uh, there is no ways we are coming up with any other model till the time we are not fixing, these basic things, like we are not fixing these neural networks working properly. We are not fixing these neural networks weights and everything. We are not fixing lot of things till the time it is not going to get very much perfect, right? So even with whatever projects, if you think that most of my code will be written by AI and it is going to be correct, that is completely wrong, right? And I have been testing this AI on lot of algorithms, lots and lots of algorithms, although I never post all of these things online because of I keep this knowledge to myself, obviously. And I have tested it on almost all the algorithms, what it can generate. If it can create new algorithms, there is zero accuracy. It can create any novel information, zero accuracy, right? It does not create any new information. So all it has is something it has been trained on rigorously. It has been trained. It has been dumped on. Even if you go ahead and you just say that, can you give me, I do not know it is happening now or not with the new upgrades, but if you go to chat gpt, you tell that give me the lead code number of this and this problem, it will tell you, okay, it is present on lead code problem number 97, right? So basically it is cramming up the data, it is remembering the data, it is not actually thinking and giving you the right output, right? So you need to remember this, right? Till date it is not happening. It might happen, and I don't see it happening in next 5 7 8 years also. So anyways, but the case being that, is it useless? Obviously not. uh, you know we use it as a tool, just like we have been using as a calculator. Now you use it as a tool. You use it as a tool, you do all of the reading part from it, you do all the analysis part from it, and then in the end you collect it and then you take the decision yourself. I have basically, there was one very big problem, financial problem, where I was working with one of the customers, and there also they were trying to automate all of the things, and they were struggling. Now basically, an example that we just heard from uh, one of our students also, that uh, basically trying to automate everything. So they were trying, since they were even using everything premium, that is everything the best, and they were trying to automate everything, but it was not happening, obviously. And then basically, like the last solution, I mean, because I knew I have been doing this, so the last solution was obviously we do all of the analysis there, and then in the end there is a human decision that has to be done, right? So this is the whole point, right? Anyways, coming back to our example, this is okay. It is saying that it has gained 97 point accuracy, and it gained long back. So there is no point in, it actually gained in first epoch itself, and it did not change. So I don't even need to go with that. I can just go with 5 epochs, and that's it, I'm done. Because obviously the data is very simple. Anyways, we have done this. Now it is time. This is accuracy. So accuracy, what is the formula for accuracy becomes? The formula for accuracy is very simple. Whatever, I mean, the corrected part out of the total part in the training data. The corrected part out of the total part in the training data. Now we have to also go with the test accuracy, right? Now we go with what should be my test accuracy. So I can go ahead and basically now I will start plotting few things. Sorry, I will start printing few things. Now basically, first and foremost thing is we go with our test accuracy, that what should be my test accuracy. So let's go first with calculating our test accuracy. So actually test accuracy is not something very different from what we have been doing this, right? Except out of the trained data, it will be on test data. So first and foremost thing, out of best practice, I'll go for model.eval. Okay. Because why model.eval? Because obviously now I need in my, I need to set my model in evaluation mode. And then output model is equal to x dot test tensor, right? Test tensor. And then I need to, okay, I get test tensor. I can go ahead with predicted test underscore output. Okay. And then correct is equal to predicted is equal to, we'll have to be careful if we are using this code. Just wait a while. Okay, torch dot max. Got it. After torch dot max, it should be predicted underscore. If this is being predicted underscore test, okay, this is the new predicted underscore y test tensor dot sum. It seems to be correct. Y accuracy, and then print the accuracy. Oh, on test, it is actually 100% accurate, because obviously the data is very small. So on test, it is giving me 100% accuracy. So this becomes my test accuracy. And next is basically, uh, false positive. I want to find out what is my false positive. So what is actually my false positive? So basically there are some, I guess, data points where it is this training is not able to calculate properly. So false positive, right? I have true positives, false negative, and true negatives. Do not get confused in all of these things. False positive, something that is positive, that is model said correctly, right? But it is not correct, right? As simple as that. False positive, right? Model says correct, but it wasn't correct. This is false positive. I mean, no brainer in this. So this is, in short, this is a wrong decision. This is a wrong decision, right? True positive, right? Now, model correctly says, and this is completely true, right? It is a model says positive, and it is also true, and it's true, right? Again, no brainer. This is the true one. Negative false, right? Again, this one again becomes the true one. Now this one becomes the false one. The model says negative, original data is also false. Model says negative, and original data is also false. Original data is also false, right? And same goes for this. Model says negative, but original data is true. Again, this is also correct, and this becomes wrong. This is the wrong data. I'm not calculating these things in as of now, because I mean, because this test accuracy is already 100%. So I mean, I'm not going to get anything in it, right? But these are very simple formulas that we just need to, what we have done this. This is the only formula, or these are the just three formulas that we'll be needing, right? Uh, I'll just quickly write down. Hold on. I'll go with. It will just take 1 minute. True positive is equal to, okay, true positive is equal to predicted. What is my predicted test class? Okay, torch. I'll write it down here itself. True positive is equal to predicted, and predicted is equal to, no, this is not the, is equal to positive class label 1 and test tensor positive label dot sum dot item dot positive class label 1, right? Predicted 1 and y tensor dot sum dot, okay, this is actually 1 is why it is taking 1, because this should be the positive label. You know, what is my positive label? 1. What is my negative label? Negative label is 0. Or in this case, basically it is just 1 and 0. I guess it is 1 and 0, not 1 and 2 here, right? So this is my true positive. It is as simple as that, right? How many are true out of that, and what becomes my false positive? And false positive is equal to, basically, I'll go with FP. False positive is equal to, again, predicted is equal to 1 and y tensor is equal to 0 and sum dot item. That's it. I guess positive, negative, false positive, and positive label class, positive y test. No, I don't think so. This is the right expression. False positive, positive label class, and y test tensor. Y test tensor, okay, is 0. Yeah, this is correct. Yeah, this is false positive, and I can just, as of now, right, true negative. And basically true negative is basically nothing. Again, we can take this true negative, but True positive and false positive are, if we combine both of them, so what becomes my precision? Precision is equal to simply true positive divided by true positive plus false positive. This is my precision. Simple, dead simple, right? I can just print my precision, comma. This is my precision. I mean, there is no brainer into it. These are simple things, very simple things. Okay, precision is one because obviously it is 100%. So it this is not going to make any sense as of now. So we'll have to switch back to the next one, next example of MNIST dataset, right? And then basically in precision itself, next is a recall. Basically, so recall becomes again true positive. Recall is equal to true positive divided by false positive plus true positive. Sorry, false positive plus false negative. It should be true positive and false. It should be true positive plus what? It should be and false. True positive, false negative. We have not calculated false negative here, so we'll go ahead and calculate the false negative again. So Fn is equal to false negative and true negative predicted 0 y tensor 1. This is correct. This is my recall, and I can just go ahead and print my recall. So these are just different terminologies to measure it, right? This is my recall, and basically I have a ready-made function for confusion matrix. So confusion matrix print all of these false positive and true positive in a matrix format. Confusion matrix using Scikit-learn. So I'll just generate, what was the confusion? Hold on. Generate and just go for generate confusion matrix. Oh, it has taken some. This is the function. Basically you just pass your y dot test and predicted here, and predicted basically what is dot cpu dot numpy. What is this being done? Because from tensors we need to convert back to numpy data. So and so once we need to pick up this predicted here. Predicted was present in my tensor format. I need to make it back into my uh, this numpy format. So this I have to do, and same goes for this also. And if I just go ahead and see my confusion matrix, so this is how it looks like: false positive and false negatives, right? Predicted and the actual ones. This is how actually it should be looking. This is very simple. I mean, so here predicted is also 31, and this is how do you read it basically. This one is dead easy to read, so there is nothing. Predicted is also 31, actual is also 31, right? And then actual is also 29 and predicted is also 29. So yeah, I mean, zero false positive, zero false negatives. So nothing into it. Now next we'll quickly, just very quickly, we'll just apply both of these things into our MNIST dataset, because the reason being, uh, I will not write this whole code either. What I will do is uh, create MNIST classification with sequential model like above, with uh, ac- train accuracy, test accuracy, and confusion matrix. Okay, so it has done the same thing, basically prediction, and then here is my confusion matrix. This time I will have to look that what is my test and train split data. It did not split the data or what? Okay, here is my split data 0.2. 0.2, that is 80% for training. Instead, I will take 0.3 so that my testing is more robust. Right. Okay, so if you see this time, train accuracy is evolving slowly and slowly, 92%. And this time, this data makes a lot of sense. The max accuracy we achieved is 92% in 10 epochs. If I want to increase my accuracy, obviously I can go ahead. There are some things that we already discussed in the previous section, and you can also now go ahead and test these things. Now, basically, although I have written this whole program in already in this notebook, which I did share with you, but what I want is at least you know try to calculate this whole thing yourself, right? Try to print this confusion matrix because it is simple as in sklearn we can simply go with. Now this time confusion matrix is a bit more complex, right? And now it becomes a bit harder to read the confusion matrix, right? uh, this is a heat map of the confusion matrix, but this is what uh, actually it looks like. Only 92% accuracy has been achieved last time. If you if you remember, because we were just using the trained data set, so we achieved an accuracy of 95% very easily, right? But this time obviously the accuracy is 92%. But believe me, with this small minuscule model running on CPU, this is so small. This model can run on your phone, it can run on your camera device, that is the home camera that you're using. I mean, this model is so small. Anyways, uh, talking about a confusion matrix, right? How do we actually read this confusion matrix? So actually, I will just hold on. I'll just show a small visualization here, and so that because this is confusion matrix reading is the most important part, and this gives you uh, and I do not know if it has given me epoch, it has given me F1, it has not given me F1 precision recall, it has not given me test accuracy, it gave me train accuracy is also 92.60 now if you see your model is very much test accuracy and train accuracy are quite very close to each other. you know what happens if we increase what is going to happen if I'm going to increase my test data? Not recommended at all, right? Let's say if I just keep it 0.1, I mean your model will be passed internally, your colleagues, your demo will run, and everything is going to happen. But as you set it in the production, it might not be very well received. It might start throwing the errors and everything. So okay, so what has happened? F1 and recall did not get calculated. So yes, I mean your assignment now includes basically for this model, for this model, for MNIST, calculate proper train accuracy, which I'm already doing, test accuracy, train accuracy, test accuracy, F1 score, recall, precision, and confusion matrix. Although confusion matrix we're already doing, but just copy this and you can start doing it. This is something you should do it yourself, right? Now you can definitely. So basically, I'll tell you one thing. Uh, Please at least look at the code and type it. At least do this thing. Do not copy paste the code directly, right? Because when you do it, your brain is going to learn at least few things. Your brain is going to remember some things, right? So go ahead and do this F1 recall and precision confusion matrix. Go ahead and calculate it. Now, let's try to, what I was trying to say that, okay, let's try to understand what this confusion matrix is actually saying here. Okay, I'll go with this. Right. Okay. So here I have confusion matrix. Now I did train on a different model. So for this demo, I mean, but it is for MNIST data only. The same number of things are present, right? Now this is actual and this is predicted one. Now if I go ahead and if I see this 915, I click. So basically 915s were actually digit 9 and the model correctly predicted them as digit 9. So this is the actual one and this is the predicted one and this is the digit 9, right? These many were correctly predicted. Now if I go with this one, two instances were of digit 0, two instances were of digit 0 and model incorrectly predicted them as digit 9. So there were two instances where the model incorrectly predicted it. So this is the actual prediction where the prediction has actually gone wrong, and this is the actual data. This is how it you need to read it. Now here again, six instances were actually digit 9, but the model incorrectly predicted them as digit 1, prediction 1. Actual is 6, but it predicted prediction became 9, right? Actual is 9, but and this is again correct prediction is, this is wrong what I'm telling basically. Hold on, it should give me the actual prediction is 11 instances of but the model, okay, this is correct. Okay, this is 9 and 9, correct, the both are 9, so this is correct, right? So actual is 9 and model also predicted 9. So this is, so if you see this middle diagonal one, this diagonal one is showing the correct predictions. Even if you go back, this heat map here, this is going to show the correct predictions here. Now incorrect ones are this one. Ideally this heat map is not showing red and red colors and blue colors, but red color is not present here. So again, take it as an assignment, right? So in the heat map, try to mark false positives as red and correct ones as blue, right? Because heat map, the idea of heat map is that with the color itself I should be knowing that what is going wrong. But anyways, uh, so what is happening here, that okay, actual and predicted, yeah, this is how you read it, actual and predicted. So let's say if I go with this one, lot of actual is uh, like the actual prediction is 6 and it got predicted as 5. 17 instances were actually digit 6, but the model incorrectly predicted them as digit 5, right? The actual is 6, but the prediction is 5, right? What I will do is, for your reference, I will put the screenshot just for the reference, I'll put the screenshot in the, right? So just you can see that, okay, this is actual and predicted, because I mean, I do not know, but initially when I was learning this caused me confusion matrix was really confusing, right? It caused me a lot of confusion. I mean, even reading today, even now, sometimes I have to sit and think, okay, what is this actually trying to say? When actually the data is big, when there are 10 classes or 12 or 13 classes. But if you see, and if the colors are right, confusion matrix give you the actual image of what is going on with your model. This will actually give you the right estimation that what is going wrong with my model, what is going right with my model. However, uh, there is one more important point, and that important point is that if you do not have enough data, then obviously your model is not learning very well. So first step again comes in that, first step is that data, and data is very costly. This is the most costlier part, right? It is not easy to get data, because if you see today, there are a lot of problems that are just stuck because you do not have data for it, right? So you should have, the more the data, the better it is. The more the data, the better it is, right? And then uh, ideally what happens now, today I just posted one image showing it, that what is the difference between AI engineer and basically data scientist. So basically, if you are AI engineer, you will get the data well refined. However, if you want to be data scientist, or if you're a data scientist, then actually I think most of the time you will be spending here. Actually, 70% of the project time is being spent here, because, and this will eat up your brain. I mean, this is really, really brain draining job. Uh, Getting the data right. I mean, in some cases, I have huge and huge corpus of data that I collected over the years. But it is very tough and very challenging to streamline that data, to properly uh, you know go ahead and label the data and do all these things. And then once you have the data ready with you, obviously you need enough data. Again, I'm saying you need enough data so that your model can train well. And now just imagine, the data is so important that just if you have enough data of something, I mean, the success chances increases huge. Now, even if you are, right, not training properly, that is, even if you are training wrong, right, but data is huge, but you have the right data, you have right data, but training is fine. I mean, you have not optimized your model, you have not done a lot of things with your model, not the proper training, not the proper training, even then it will be far better than best model, or best, if you have the best model in place, you have very high-fi GPU, less data. If you have less data and you have the best model, this model is still going to outperform. This model might still be struggling at some 80-85% of the accuracy, while this model, even after all of this, might be at 91 to 92% of accuracy. you know and hence these big companies, why is Google able to beat in the game? Google started the last. Google is the last. Only the company that has data is going to survive in this battle of chat gpt, and then you have Gemini, Claude. And why has Claude started struggling? Data. Because obviously you cannot invent anything new in such short amount of time, right? No one is going to invent anything, although everyone is just trying very hard. Whosoever has the maximum amount of data is going to win. Obviously, this chat gpt guys, they have taken the data from everywhere, and what they did is basically, after taking the data, they have basically put it in their model. But obviously there is hell lot of data that is present with Google, right? Google has lots and lots of data, because obviously it is a search engine. It is storing your data since what, 3 decades, and it has been storing your data, and they save the data. I mean, they keep the data with them. Every search, everything they are keeping with you. And now, it is not that they have some better architecture, but slowly and slowly their models are getting better. They're coming up with more things. And this is why, only the companies who are able to beat others are basically just who has the data. Anyone who has the data is going to win in this game, right? Now, talking about, again, this dilemma is very huge. This is very huge. What is huge? That, again, I'm telling you that, just 1 minute, right? right? So what is, again, I'm again repeating this thing because this is again very important. Poor data, poor data with best model plus best model, right? It will always give you average results. Average results. Good data plus average model. If you have average model, it is going to give you the best results. So it is data that is important. It is data that is important. Now, if you start just if you start reverse engineering, right, and you see that all of the innovations in AI, they have been coming only in the area where data was present. The Ghibli, why it happened to come, why it is coming? Because in Japan, eventually, what is that downloading and using Ghibli is they it is legal, right? There's a law. I mean, exactly, I do not know the law, but there is something that you can use Ghibli. So basically, they misuse that law and they trained with their models. Why all of a sudden, they're coming up with only Ghibli? Because they collected that data, and I don't even wonder that there might be one company that might have sold to all of these companies. That is one company that might have sold the data to all of these Claude uh, and Gemini, Chat GPT, Anthropic. There, I mean, I'm just saying that might be a possibility, right? So they collected all of these data and then they dumped it and they just trained it. Now they have, obviously they have GPUs, right? And they have the data. And once you have data and GPU, you have your model in place. This is it. So most of the time, the company, when they suffer with the AI, or if there is something you want to build next for your big for your AI, make sure you have a good data labeling team and you spend enough time in data labeling, because just with data labeling and an average model, and you have fine GPUs to train the model, you will be able to break through your competition. It may be any competition, any kind of competition, you will be able to break through that. Right. Any doubts in this, team? Any doubts?
No, no.
Okay, cool. Right. Okay, so what did we basically, we just have established a very basic version of what is basically a model and everything, and how to evaluate the model and how important the data is for us, all of these things. Right. Now, the next thing that we want to switch towards is basically the textual data. I mean, for which all of the things that we have been waiting. But yes, I mean, it is not that immediately we are going to switch to LLMs and everything. We are going to take one step at a time. Understanding of the text data. Right. Now, question number one. This model that I created, model is equal to, the model name is sequential, and then that dot sequential, right? And then what it does is nn dot linear, right? Nn dot linear, okay? And then nn dot relu, right? And then again nn dot linear, the most simplistic model. Can this model process text? Can this simple model process text? Yes, it can. So basically, if you put in the right data, yes, it can, but it will have its own limitations. We'll talk about the limitations. For first demo, maybe I will give with this only, but eventually as we go ahead, there are a lot of things that we need to take care of, because I mean, there is three layer of transformation that will go through this. One is obviously what we are going through is, first and foremost thing is that these simplistic models will not work anymore. We'll have to learn how to create advanced models, right? Learn advanced models, right? Not just that, we'll have to learn how to use these models. Second, obviously, as of now, what my model is doing, my model is basically, let's say this is my data. This is what it is doing, right? All of the information is discrete information, right? Every information, but are my sentences discrete? Although yes, they are discrete. Let's say I say that I am crossing the road. I am crossing the road. Is it a discrete sentence? I mean, I am crossing the road. If I just cut down these sentences, right, will the meaning change? If I just remove this, if I remove this crossing, I am the road, the whole meaning gets changed, right? So this is not a discrete thing. I mean, this is not different. So sentence only makes sense when it comes, all of the sentence, it comes in together. Only then it makes sense, right? That is, only this whole sentence, once I see it, it is going to make sense, right? Now, if I say that, okay, you know what I'm trying to do, I am crossing the road. If I do this, will it work? Yes, obviously. This is a neural network. This is, or I call it, let's say, a calculative engine. Its job is to calculate. It will do the calculation, right? It is not going to collapse until unless its calculation goes wrong. Like we saw one of the problems, like exploding losses, right? The losses were getting too big in one of the, I guess last week we saw that, the losses. So until unless, either loss or gradients or anything, just either it might go too huge or it might go too less. So just like a calculator, I might, there's an error it shows. As of now, it is not showing any error. I mean, the framework simply goes on calculating. This is and basically we just have to look at the values and take a guess that what is happening. So basically, the first point being that yes, what I can do with this, definitely this neural network might not be applicable for very advanced applications. But can this neural network at all be used in something? Yes, it can be used in something, but not everything. Now, let's first try to understand that, since I just highlighted one point that, this is not a discrete structure. A sentence is not a discrete structure. It takes everything in the context, right? So what we say that I am I am learning PyTorch with Hugging Face, right? Hugging Face library. I'm learning PyTorch with Hugging Face. Now, so this is complete one sentence, and my AI has to understand, this was a very tough job, and believe me, we have just solved one very important puzzle, and hence we are seeing so many applications. You know, that is, what is the relation of I? What is the relation of I with PyTorch? What is the relation of I am with Hugging Face? You know, just imagine, we scratched our head for years and years, and I remember very well remember that time back in 2016 and 15. I mean, there was just no way around. So what I used to do, I'll tell you that. I mean, now that even method is obsolete, not obsolete. I mean, people don't even recognize, although that method was very much effective. So basically, I had we did write one small program called as, that was called as dependency parser. Let's say I am crossing the road, crossing the road. So basically, I wanted my, there was no transformers at that time. Transformers is basically a technology that has solved the problem of understanding relationship between the words. You know, so basically earlier what we used to do is I am cross, and cross is connected to road. You know, this is how it is connected. Now basically this is like a relationship, and then we used to take these relationship and feed it into the neural network. We used to take this relationship and then we used to feed it in the neural network, right? And then from there, there was huge amount of like text that we started classification. We started classifying that text, and the accuracy was very good. Actually, it was not at all bad. You know, those models we used to train on CPU. We used to train on, there was, I mean, the cloud infrastructure was also not there, right? So we used to train on CPUs. I remember training one model for 3 days. My first chatbot that I trained back in 2015, right, around 16, 2015, 16. I downloaded all of the data manually from Reddit. I downloaded all of the data from Reddit, and then I trained that data on a very plain neural network. But however, that neural network, since the data was huge and huge and huge, I trained it from scratch, and it took me 2 laptops and 3 days, I guess, 3 days to train, continuous 3 days. And then I had a model, and basically I demonstrated also to a lot of people, and basically it used to do the chat. I mean, although it did not chat exactly rubbish, but yes, I mean, I was able to chat with it, and it did make sense. I used to ask him that, okay, what is this, what is that, and all of those things, and it used to answer me. We'll build that kind of chatbot very easily in going forward in this course. I mean, that's a very easy thing, right? Anyways, so what I was coming to the point that, okay, relationships are important here, right? The relationship is very important, and this is where what we can build and what are the kind of applications with the text that we are about to see, and with each and every application, what kind of technology gets associated with it, right? Okay, so okay, so first and foremost thing is obviously the first application is text classification, right? What does it mean? Text classification. These are still very relevant. It is not that these are irrelevant things. Text classification is basically you have any text here, and from that text, actually, what you're trying to do is from any text, you are trying to classify if this text is, it may be you might be able to classify into sentiments, that angry, happy, or something like that, or you can basically just go ahead and classify into whatever you wish to, right? Let's say in for medical terminology, let's say I can go ahead and I can say that I want to classify if this is a warning from a doctor, or if this is a prescription. What kind of is this? If warning, prescription, medicine name, whatever it is, right? This is first and foremost thing. Text classification is the thing. However, the second application that comes into picture is, the second application is basically identifying, identify entity, identify entity, right? What does identifying entity means? Let's say I am saying that, you know, I love to go to, I love to go Paris, right? Or I can also say that instead of I, it can be some person. Let's say anything, that Ram loves to go to Paris, right? So here we talk about Ram when we are talking about Ram or whosoever, right? So this is a name. This is a name. And then we talk about Paris. What is a Paris? Paris is a city. So it should automatically recognize. And then not just that, it should also be able to devise the relation. What is the relationship between these entities? Let's say I say that anything again, Ram and Sham are good friends, right? Now here the entity is person, person one, person two, and the relationship is friends, right? So this is friends. So it should be able to identify a relationship between these two things. Then what's next? Next is obviously generation. Text generation is the next thing, next big thing that we should be looking at. That is, generation is actually, I should call it autocomplete, because everything first, everything is autocomplete, you know. Now if you just see in chat gpt what you have been seeing, that autocomplete first, it started from your WhatsApp. In WhatsApp, you used to write anything like, hey, how, and it automatically suggests, it suggests how are you, right? And basically these suggestions are very personal to you, right? And how does it happens? Obviously it happens via AI model, right? So this is autocomplete, right? And then this autocomplete actually further took the next step. This is autocomplete only, and they called it as question and answering. Question and answering. What is question and answering? Basically, question and answering. I do not know how to move it. Okay, never mind. In question and answering, what is happening here is that basically you ask a question, you ask a question, and the AI model will answer you. This is one way in which it has been trained, you know, question answering. And this is what your each and every chatbot is. That is, it may be Chat GPT, Claude, whatever, right? They are question answering models. They're question answering models. So basically, you ask them anything, they will answer you. In fact, question answering is extension to autocomplete. Basically, you ask your question, right, and it auto completes you. It completes that. Basically it internally it is trained in form of autocomplete, but it is a question answering model. Question answering models are of two kinds, right? I'll have to make more space. There are two kinds of question answering model. Q&A, right? It comes into two forms, although you know only one, but there are two forms to it, right? Before even chat gpt was there, I mean, usually question answering was there even then also. And I was able to put a question answering model in production since very long, I mean back in 2017-18, right? It became popular with the public with this, basically. So basically Q&A, what was the point? That this one, we used to call it basically open book model and closed book model, right? So this, we used to call this as open book model, open book and closed book model. I'm using a very layman term as of now. Closed book model. Now the name is very simple. What is an open book thing? Open book means obviously it will answer you, but you will have to give the context of complete book. You will have to give the context of that complete book, and then you ask a question, anything from that book, it will fetch the answer from that book and it will answer you. And what is closed book? All of these models, Chat GPT, etc., Chat GPT, Claude, and all. These are all closed book models. These are closed book models. What does closed book means? So in closed book, basically inside the model only all of the information resides, and hence these models become very huge. Inside these models, the information resides. However, in open book, the model is sleek, and all of the information might be residing somewhere inside your maybe PDF. Ideally, it's not PDF, right? Uh, Usually, it is some kind of good database, NoSQL database or something like that, NoSQL DB or something like that. Right? Nowadays, actually, it's vector DB. It's vector DB. Okay, nice finding vector. What is this vector? Right? We'll see. I mean, we have a visualization, and first, our first example itself will include a vector. Right? What is a vector? We'll see that. Now, this was the closed book, and this was the open book model. Closed book and open book model. Okay, all right, and NoSQL DB. So, and then what is the next application? The next application is basically you can even we have the generation use case, and after the generation use case, basically we have text to image or text to video. I will say text to media, text to media, and media to text. Anything you can take. You can take text to media, and you can take text media to text, right? So this is again, it falls into this category only. But yeah, I mean, which actually now comes in form of multimodal. We will have one, I guess, session over multimodal models, but our most of the time is going to revolve around these kind of models only. All of the things that we discussed, that is, uh, first we'll go with the classification problems, and then first we'll actually learn how to build models, and then we will have to go through basic models, so recurrent neural networks. We'll have to learn how does RNN works, and RNN along with it, there is another one, architecture. Now these are all architectures of neural networks. How does LSTM works, and along with LSTM, we then next step is that how does attention works. That is, attention is basically finding the relationship between various uh, words, right? Finding the relationship between various words. And after attention, basically, how does next step is transformers. Now, this is the big thing that happened in 2017, and the paper was released in 2017, although applications we started coming in 2019 and 20. I mean, after 2019 and 20, there were a lot of applications that started coming. And once this happened, basically transformers, once this happened, and everything, the word is changed. And this is basically the architecture that we'll also have a look. We'll see how to build one from scratch also, and then slowly we'll also see how to create, how to utilize the existing model also, right? And for that, basically, for further training the models, we'll use the library of Hugging Face. We'll use HF, right? Right. Going back to this, right now, it's time for a very small demo. I'll start very light because you already have few things to practice, and I am not in a mood, to just introduce you something very heavy to you, because obviously I'll just have one. So we'll just have very simple introduction to how text works, although because I'll have to revisit this whole theory in the next session also. The reason being, obviously, there is a small twist into it, right? That how does all of these things works. So exercise 7. But like I had already said you that, is it possible that the same model can be used for text processing? Yes, it is possible. It can do some kind of text processing, right? And actually, since why the reason being why I have been taking you since the very basic. Go ahead, create your models, start playing with it. uh, you can discover even what nobody has discovered. You can go ahead and discover what a lot of people might not have discovered. So why I'm saying this, I mean, there are a lot of loopholes. You will see that when we are, just covering this theory, you will see that there are a lot of things, there are a lot of things we had to do, because I mean, this is, we know it works, so we had to do it this way. And you will feel that, what if I could do it in another way, would what if I could do it in another way? Obviously, people have tried, and but yes, you can go ahead and keep on experimenting and lot of other things, right? So hence this whole PyTorch framework was given to you. Okay, so I'll start on with a very simple basic example. Okay, let me find out the data set. We'll take the data set of, let's say, from Scikit-learn itself. Anyways, we'll not go with the data set. So let's first just start with few sentences itself. We'll start with few sentences, right? Now, there is somewhat twist here, and the twist is that how are you going to make this model understand? How are you going to make this model understand that, what is how this model is going to understand that, how should it understand the text basically? So I'll go here back again, saying that, you know, we might have any text here. Let's say I again take some text. First and foremost thing that, hello, how are you? Hello, how are you? Now this text needs to be converted into numbers. We need to convert it into numbers, right? And what is the process of converting this text into number basically? Because our neural network will not understand anything apart from these numbers. It is not going to understand anything apart from these numbers. So it understands only numbers. So we need to convert our text into numbers, right? And what is the easiest way to convert this into numbers is basically called as, we can first assume that, let's say I have complete book here. So I might have a complete, or I might have a first page here, right? And I'll actually show you with the visualization. Just hold on. Yeah. So basically, what we need to do is, like I was telling you that this is my sentence. This is my sentence, and I need to convert it into numbers. There are many ways we can convert this into numbers. I mean, people have been, although since 1970s, people have been converting this into number, because this whole uh, branch of AI dealing with text is called natural language processing. We call it NLP, right? So NLP was active since 1960s and 70s itself. I mean, it is not a new thing. Earlier, people came up with some static numbering system for each of, there are limited words in a dictionary. Limited, I mean, still there are uh, in lakhs, but still, I mean, still you can count them. And people have done is people have gone and numbered them manually also. But yes, I mean, as we grew up with the technology, things changed. We established many new things, right? So step by step visualization. And what is your, this is my dictionary. Dictionary means these are the words as of now I support only these words. That is my mod. I can increase this, right? Let's say if I want to increase this something to uh, India, I can increase this, yeah, or USA, I can increase this whatever I wish to, right? So my vocabulary increases. Ideally, there are a lot of predefined vocabularies that are present. We'll use them only. So this is my vocabulary. This is my sentence, right? And this vocabulary, now if I just go to this, okay. Now my vocabulary, if you see word, every word has a position. So I has a position 0, love has position. So these are the numbers that are automatically assigned to this, right? These are the numbers that I have automatically assigned to this. 3 to product, 4 to amazing, 5 is great, 6, 7, very simple, right? 9, 10, I mean, kids' job in second and third, this is how we used to do, right? And then what we have done next, okay, hold on. Is no one able to see my screen?
Yeah, I wasn't able to mix. It was just stuck at this
Okay, okay,
same.
sorry. Can you see it now?
Yeah, step by step text to it.
Right, 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 right. Correct. Okay, so sorry, I'll have to restart. So basically, step by step. So basically, what is happening? This is my dictionary. This is my dictionary that is present here, right? What is dictionary? So basically, the dictionary, me, what I mean is that in my dictionary, everything will be like, so this is my basically dictionary part. In my dictionary, what I have is that all of the words that are present. So as of now, for demonstration, I just have limited words. I just have limited words in this dictionary, right? And then this is my sentence. This is my sentence here, right? Now, if you see, I'll just go with the next step, that is start step by step visualization. Now, as I've gone this, here in this part, if you see, it has simply what it did was every word is having a unique number, and this is 1 2 3 4 as it was present, in the same order. So we did assign simple numbering to each and every word. Each and every word got a numbering, right? Each and every word has a numbering. And once this is done, next is the interesting part. Now I will just restart it again, right? Now if you see, I'll just restart it. I love amazing apple. As of now, all of my words that I have, they are present in this dictionary, and I'll just start step by step. So here what is happening, it has started to build my vector. Now this is the dead simple one, right? Just hold on, let it finish, and then we'll try to understand that what it is actually building. So basically, based on this position, right, my total length is, this is my total length, that I have a total of 12 things, right? I have a total of 12, and out of 12, what it has done is it has, out of this 12, this was my vocabulary initially. Let's say my vocabulary had something, uh, 1, 2, 3, 4, and 5. Let's imagine this. Now, what it has done is, out of this vocabulary, and let's my word was present at 1, third position, and fifth position, right? These are the words that I have. So now, what is a vector? It says that wherever your word is present, I will mark it as 1. Is it present here? No, it is not present. I will mark it as 0. Present here, I will mark it as 1. Present here, I will mark it as 0. Present here, this. So this is how it has encoded my information, and this is one example of very simplest vector. In fact, here actually the only information I am capturing here, I am not capturing any information as of now. The only information that I am capturing here is position in the dictionary, right? Position in dictionary. So since I'm only capturing this information, so obviously this way is not going to go too far, right? So in real time, when I go, I will need multi-dimensional data along with position, right? I will need more information like, what is position, what is meaning of this vector with respect to, does this word has any relationship? I will need relationship, right? And I will have, okay, position I already have. Then any grammar thing if I want to put in here, any grammatical thing do I want to put in here, right? And so on. So ideally, there are actually 70 to 80 dimensions easily that are present in every word, and it goes on learning. I mean, you don't have to do it yourself. This is just for understanding. But as of now, if I want to feed my data into my network, I will need this kind of vector. This is called as vector. This is called as vector. Basically, why it is known as vector? Because it is storing all of the information, you know, that is present inside. As of now, it is only storing positional information because this is a very simplest format, right? Going forward, we will have lot of other information that will be present in many other formats, right? I mean, ideally, this is only going to be, but it will just have multiple dimensions, because in multiple dimensions we will store various features. Right now we have just stored positional feature. Next, going forward, we'll store other features like how it is closely related to other feature, position number 2, 3, 4, 5, 6. And this is how we'll go on to understand the meaning of each and every word and sentence. So basically, as of now, what we have done, this is my sentence vector. I'll go back to our demonstration. This is my sentence vector, right? It is having 12. Now, what if I in let's say, what happens if I enter something that is not present? I love India. I love India, right? And India is not present in this, right? And I go again step by step. I love India. I love India. Now it is again building this. Let it build it. Position is present here. 12 position. 12 is the maximum size. Positional vector. And ideally, what it has done for India, you see, it has given 0. Now, normally, instead of 0, we usually mark something else like -1, not found kind of thing, right? NA or any word you can take, -1 we will take, right? But going forward, it is actually marked as NA, right? Or there is a small tag that we introduce that becomes a standard, that unknown, UNK, unknown, right? That is a small tag that but I did not, for the worth of understanding, for the sake of understanding, I did not introduce it here. Now, what happens if I introduce this word here? If I introduce this word here, my vocabulary is going to increase. My vocabulary is going to increase. This is going to increase. Plus, India will now be encoded, right? Let's try it out. But India is the last one, so it will be encoded in the last one. You see, step-by-step visualization again. It says, okay, I love, found, India found, and okay. Now you see, this is for India. This one is for India because it was last here. If I move it somewhere here, then obviously it will be somewhere here, right? Let's say if I just go for Amazing India, again, I mean the same thing. This concept is, now it is not that easy one, but due to all of these visualizations and everything, it becomes easy. If you just go to any 2 3 4 years of data scientist or AI engineer and you ask him, what, can you tell me the process how a word is actually converted into uh, a vector? Some might be able to tell, but a lot may not be able to tell this. A lot of them may not be able to tell this. And most probably, if you ask them, what, I give you this amazing India, and you tell me, so this is how it has. So this is positional vectoring only. This is positional vectoring. Now, this will only contain limited information. Why it is only containing? Obviously, it is not containing any information that what that word is about. What is the relation to? We are not containing any relationship between these two words. So as of now, we have just done is we have just entered the vocabulary and we just mark the position. So obviously, for some simple applications like classification or sentiment uh, analysis, we will be able to do it. But as soon as we see some tough sentences like, let's say, this kind of application will easily be able to learn that I do not like movie, right? Straightforward. It will easily classify, this as, negative, negative. But I never said I don't like. This is again confusing one, right? So in these kind of things, because it did not learn to understand the relationship, it might end up saying negative, which is a wrong one, right? So this is the limitation. This is one limitation of these kind of things. But anyways, we will be starting with this kind of application only. We will be basically going forward and we will be uh, using this sentence. So basically this will be our sentence, and then from this sentence we'll be creating this vector, and this vector can easily be passed on to the model we have been creating till date, and then we'll go ahead and try to train a model for sentiment classification. But then, since this kind of model has certain problems, the next we'll try to learn how to transform, how to learn relationships, and then we will introduce a new thing. Basically, there are many new things that we need to learn before we need to jump into that. So yeah, for today I'll keep it short because there is, I mean, if I start, I mean, it will be another 1.5 hour that I'll have to take. So I keep this short so that this also is actually kind of marks the end of our pre sessions that we had kept. So I'll just tell all other information. I'll just finish off this recording.